We're out for a flight of the Vampire. We've got a crosswind about 80 degrees from the left, so that's a bit annoying for our runway.
Throttle active. Have you reset the timer?
20.5 volts, 0.1 amps, 2 mAh.
Ready to go.
14.2 volts, 37.1 amps, 63 mAh.
They're only getting 37 amps
16.1
off the
volts,
takeoff.
12.9 amps, 121 mAh. 16.2 volts.
So we're only getting 16.2 volts out of this battery. That'll rise because it's a bit of a cool day. So as the battery warms up through the current flow through it, the internal resistance will reduce, and then it'll be able to supply more current. But it is still pretty low. 16.7. We might get up to 17 region.
367 mAh, 4 minutes. 17 volts, 19 amps, 407 mAh. 17.2 volts, 18 amps, 444 mAh.
Using 18 amps, which is probably a good enough speed. There's a little bit of wind, so I want to fly a tiny bit faster than normal.
17.2 volts, 18.1 amps,
help offset the buffeting.
17.2 volts, 17.6 amps, 549 mAh. 17.2 volts, 18.1 amps, 584 mAh. 17.2 volts, 17.8 amps, 619 mAh. 17.2 volts, 17.9 amps, 654 mAh. 3 minutes. 17.2 volts, 17.7 amps, 689 mAh. 17.2 volts, 18.2 amps, 700.
We'll gain a little bit of height and come around for a loop.
17.2 volts, 18.1 amps.
It's better off coming. Probably could do it off a flat entry, but it's better to be gaining a bit of speed on a downhill run.
17.1 volts, 18.2 amps, 829.
So turn around, come down, full power.
15.6 volts, 39.4 amps, 800.
More than enough power.
17.3 volts, 16.3 amps, 928.
Always does those second half of a roll
16.9
like double the rate of the first half. It's very hard to catch it, so that you slow it down via less aileron in time. So let's give it another try. So it just flings over as soon as it gets roughly 270 degrees, or maybe 200. Anyway, doesn't matter.
16.9 volts, 20 amps, 1130 mAh. 17 volts, 17.8 amps, 1166 mAh. 17 volts, 17.6 amps, 1201 mAh.
So the voltage to decide to land is sort of relative to what was the voltage when the battery had warmed up a bit and was at a stable area, which in this case was about, I think it was 17.3 volts. So we're at 16.9. I could probably go to about 16.8 or 16.7. While if you're only using this 18 amp range, if you use more current, the voltage will get dragged lower, so the number you got to use is lower.
16.8 volts, 17.5 amps, 1407 mAh. 16.7 volts, 17.4 amps, 1441
16.7. That's getting close to where you would decide you better land. The landing gear's down.
16.7 volts, 16.
landing, low level landing flaps.
506 mAh, 16.6 volts, 16.3 amps, 1538 mAh, 16.6 volts, 16.3
Full
amps,
flaps, that'll start slowing it right down.
mAh, 16.9 volts, 12.3 amps,
I'm down at about 10% throttle.
mAh,
Commence landing procedure.
18 volts,
Going for a
3.2
mile.
amps, 1614 mAh, 18.3 volts, 0.3 amps, 1617 mAh, 18.4 volts.
So you see the voltage is coming up once it's the load's dropped off it. We're up at 18.4 volts. By the time I get back to the pit area, would be more like 18.6, which on a 5 cell means you're going to be around very low 3.7 per cell region, like 3.71, 3.72. So in the end, even though it's flying around, those numbers are extremely low for a 5S battery. It's only because the internal resistance of the 20C battery, which is really 10C, is very high, and that current level is actually not a problem for the battery itself physically. It's the voltage is dropping because the IR is so high, because you basically got a voltage divider between the battery's internal resistance and whatever the power is going to, which is your motor ESC. So if your battery resistance is higher, the voltage divider, you've got higher resistance on the battery half of it, so more voltage drops over the battery. So therefore you're metering what is coming out of the battery, or at that junction between the battery and the motor. So you're seeing 16.6 volts rather than say 17, 18 on a very good battery. But that the battery being pulled down is not necessarily a bad sign. It's a bad sign if you had a graphene pulled down to that. If the battery was a low IR battery and you pulled it down to that, then you're really stressing it. This battery, like, is not even warm at all.
RSSI level critical.
Because that low amount of current
Telemetry lost.
isn't bothering it. .7, only 0.01 across cells, so 3. Don't know if you can make it out on the camera. 3.73, 3.728, 3.73, 3.73. They're all going to be in that region. So the battery's faintly warm, hasn't even cared. Sounded bad numerically. So I've outlined the reasons why, and this is why you need telemetry and some knowledge of your batteries and their IR to work out what is truly going on in the plane, rather than, oh, that sounds bad, I better land. And there was no need to ever land, because there was no issue whatsoever.
Welcome to the FR Sky Tyrannus.